Hello, this is Taylor Brackenbury, and this is my presentation on the general circulation of atmosphere. Air in the atmosphere moves around the world in a pattern called global atmospheric circulation. It is caused because the sun heats the earth more at the equator than at the poles. It is also affected by the earth's rotating. In the tropics near the equator, warm air rises above the Earth's surface and starts to flow away from the equator and towards the poles. Air that rises north of the equator goes north, and air that rises south of the equator goes south. When the air cools, it drops back down to the ground and flows back to the equator and warms back up. The warm air rises again and repeats the pattern over and over. Wind direction. Wind direction. Wind is affected by pressure gradient, the Coriolis effect, and friction. Wind is always reported by the direction it comes from. Air pressure flows from areas of high concentration to low concentration. So looking at the air pressure on isobars can indicate the direction of wind flows. In a high pressure system, the winds are moving away from the center in a clockwise motion. In a low pressure system, they move towards the center in a counterclockwise motion. Since we live in the U.S., most of the winds are northwest winds. Winds along the equator come mostly from the east and are called trade winds. Directly along the equator is an area called doldrums that has extremely low pressure and the winds are very calm. In all locations in the world, local winds that are close to the surface can come from any direction. The Coriolis effect. Wind moves in a straight line from areas of high pressure to low pressure, but it actually follows a curved path. The curving of the winds is caused by the rotation of the earth. This is called the Coriolis effect. It describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances around the earth. The Coriolis effect causes wind to curve to the right in the northern hemisphere and to the left in the southern hemisphere. Why and where air rises and descends. Warm air rises, creating a low pressure zone. Cool air sinks, creating a high pressure zone. As we know, air flowing from areas of high pressure to areas of low pressure creates wind. The greater the pressure difference between the zones, the faster the wind moves. I read quite a few examples using a balloon. When you inflate a balloon, the air molecules inside the balloon get packed more closely together than the air molecules outside the balloon. This means the density of air is high inside the balloon. When the density of air is high, the air pressure is high. The pressure of the air pushes on the balloon from the inside, causing it to inflate. When you open the top, the high pressure air flows out quickly to the low pressure air. How the general circulation of wind impacts climate in certain areas. Global air currents causes global winds. Global winds are the usual winds at a given latitude. The winds move air masses, which causes weather. The direction of the wind determines which type of air mass moves over an area. For example, a west wind might bring warm, moist air over an ocean. An east wind might bring cold, dry air over a mountain. Which wind prevails has a big effect on climate. Global air affects precipitation. This varies with latitude. Where air rises, it cools and there is precipitation. Where air sinks, it warms and causes evaporation. These patterns are part of the global wind belts. As you can see from the examples on this slide, different things happen at different latitudes due to climate and air currents. Tornadoes. Living in Oklahoma, we know a lot about tornadoes. They come from low pressure zones due to atmospheric instability, allowing air to move vertically upward. Funnel clouds move down from clouds and rotate cyclonically. Oklahoma gets so many tornadoes because of large air masses. The different types of air from other states like cold, dry air, warm, dry air, and moist, warm air all meet in our area. This is why it is called Tornado Alley, and Oklahoma is definitely in Tornado Alley. Thank you for watching my presentation. Thank you for watching my presentation.